Hello, my name is Paean, and I'm a senior at Franklin this year. By the time this video premieres, we will have passed the 1-year anniversary of Franklin's shutdown from COVID-19 on March 13th. 2 days earlier, the Louisiana Science and Engineering Fair had announced that, for the first time in history, its on-site scheduling was canceled. Franklin's independent science and research class has been, since its 2018 debut, an environment where students can initiate innovative projects involving human participants, university labs, and even the Audubon Zoo. With the pandemic calling for social distancing mandates, many of these studies are no longer safely possible. That being said, here are 3 projects from Franklin kids in 2020 that came through against the odds.
So my research project was a video game that was made to teach while the player plays it. There are tidbits of global warming spread throughout the game. The results weren't quite as expected. They were slightly lower than we would have thought. They did not yield much learning nor fun, but that is most likely due to the fact that I did not have access to surveying children of the target audience. I had to settle for people of an older age. Next in the development process is updating the game or creating new games that have the same premise of being fun while learning.
Hey, my name is Lyle. So I spent COVID with my grandfather in Michigan, the area that he's lived his whole life in. But unfortunately an area where factory farming, termed CAFOs, or concentrated animal feeding operations, has become pretty prevalent. And also an area where there's a high density of inland recreational water bodies. CAFOs have potential to produce massive amounts of waste, hundreds of millions of gallons of liquid manure annually. And obviously this waste has the potential to run off and affect these lakes. So for my project, with the support of a local group up there, I was able to test at a number of lakes in southwest Michigan, doing a full water quality index at lakes with varying CAFO proximity, and thus look at the effect that CAFO proximity has on water quality. I found weaker correlations with some other water quality parameters such as phosphate levels, and even dissolved oxygen in instances. Overall, I was able to collect enough data to come to the conclusion that about 46% of the variability in specifically E. coli concentrations of lakes in southwest Michigan can be attributed to CAFO proximity and lake size. I was also able to send off some samples of water to a lab in Detroit where they did some more advanced water testing for me, some microbial source tracking via PCR. And they confirmed that at least some of the E. coli bacterias that I was testing were in fact coming from CAFOs, from the gut of pigs or cows specifically, because there are wild deer and geese and duck populations in the area that could also be responsible for E. coli levels. But I definitely think that this is something that's still of great concern. There's a lot of work to be done with regards to CAFOs, whether that's figuring out a way to more sustainably raise animals in the United States. Crazy statistic, I think it's 99% of the farmed animals raised in the United States are raised in APHOs or CAFOs, which is unbelievable. Or to figure out how to increase the protections placed on CAFOs, and limit their impact on the environment. Because right now there aren't adequate legal protections on CAFOs. They're mandated self-reporters. There's no zoning, things like that could definitely be changed.
My name is Helena, and this year I worked on developing a computer model that forecasts the impact of COVID-19 on Orleans Parish. So, after researching several other epidemiological computer models, I concluded that there was a need for an improved one that could balance scalability, simplicity, and accuracy. For example, there's this model called the SIR model that stands for Susceptible, Infected, and Removed. Basically, it cycles through those 3 stages, and it's pretty simple, but it is not that accurate. So first, I started by building a part of the code that would generate a synthetic population. I used a random number generator to assign attributes such as age, biological sex, and underlying health conditions to each agent or person in the population. This would ensure that the demographics of this virtual population would match the actual demographics of Orleans Parish. Next, I implemented a formula that could calculate each person's hospitalization and death risks. I derived this formula from Mathematica's 19andMe website. Third, I wrote the code that would simulate agent movement across a 2500 by 2500 grid. Each day, the agents would travel to 4 locations: home, work, and 2 random locations. So after getting all this movement set up, it's time to introduce a few infected agents into the population. So as these infected agents interacted with other agents, a series of logic statements would run, and this would determine whether a non-infected agent would get the virus or not, and how getting infected would impact the agent. If agent 1 is infected, it'll then check to see if that agent's hospitalization and death risks are high enough. If they are, that agent will either be hospitalized or eventually die. If not, they will simply recover and return back to the susceptible population. As agents move around infecting one another, their status each day is stored in this huge data frame, allowing me to keep track of the changes in population over time. And finally, the model would sort and compile a list of all the infected and dead agents and group them based on certain demographic traits. Using this information, I could then compare what my model predicted to what actually happened. These graphs show what my model predicted in red versus what actually happened in blue. And as you can see, everything except the female column did a pretty good job. I would also like to note here that the light blue part of the infected column corresponds to an estimate of the actual cases, where the dark blue is the number of reported cases. So if that estimate is correct, then my model actually did a pretty good job. It took 4 hours to run, which is a crazy amount of time for only 400 lines of code. Even though I only made it for Orleans Parish, that is much larger than most models' population sizes. Like, most models really focus on like a neighborhood size level. Orleans Parish is much larger than that, so I was happy with that.
Helena and Lyle will both be competing in the virtual Louisiana Science and Engineering Fair from March 22nd to the 26th. Lyle will also be competing in the virtual International Science and Engineering Fair in May. Good luck to them, and thanks for tuning in.